Okay, so last section, we're going to look at our conic sections. Okay, 4 basic conic sections are circle, ellipse, parabola, hyperbola. Today, we're really going to study the ellipse. Tomorrow, we'll study the hyperbola. Okay, well, let's take a quick look at the parabola. Okay, so this is a parabola. And what I've done here is I have a little thing up here that's going to measure the distance between A and B. Okay, and it's going to change as I move it. And it's going to measure the distance between B and C. Okay. What do you notice about those, if I can drag this again, what do you notice about those two distances?
They're the same.
Yeah, they always stay the same. Okay, it might change a little bit because of rounding, but it looks like they're pretty much staying the same. And that's basically what the definition of a parabola is. Okay. The distance from any point on this parabola to point A, and the distance from any point on the parabola to point C always has to be the same. Okay. This line has a special name. Okay. It's called the directrix of a parabola, and A is called the focus. So the fancy way to say it is the distance from any point to the directrix and any point to the focus always has to be the same. As long as that's true, your shape will be a parabola. Okay. And there's 4 basic parabolas. It can open down, it can open up, can open left, and it can open right. All right, and that's all I'm really going to say about parabolas. All right, so that's the parabola, and that's the conic section you get when you slice the cone at an angle going through the bottom. Now we're going to take a look at the ellipse, which is the conic section when you slice the cone at an angle, but you go through the sides of the cone. Okay, you don't come out the bottom. Let's take a look at the ellipse. All right, so all of these shapes we're studying, they're all two-dimensional. Okay, they're all flat. So they are a collection of points in the plane. Okay, if I was going to define a parabola worded just like this, I would say a parabola is a collection of points in the plane such that the distance from the point on the parabola to the focus and the point on the parabola to the directrix is always equal. Okay, ellipse is a little different. We're not just measuring a distance from a single point. We're measuring a distance from 2 points, and we're adding them up. Okay, when I show you the picture and move the point, I think it'll make more sense. Okay, so an ellipse is a collection of points in the plane, such that if you measure the distance from 2 points, okay, inside the ellipse, to the point on your parabola and add them up, it's always going to come out the same. Okay. What does it come out to? Well, it depends on the size of the ellipse. Most of the time, we're never even going to figure out what they add up to. We don't really care about that. All right, so I can put that right back up. Let me just show you the, let's see, ellipse. Okay, so here's an ellipse. Those 2 points I was talking about measuring the distance from, I've called them B and C in this picture. Now, the length from E to B is going to change, and the length from E to C is going to change. But when I add the 2 distances up, okay, watch what it always adds up to. Okay, see if I can just click the point. All right, so notice the distance from E to B is changing and E to C is changing. But if you add the 2 distances together, you're always going to get 17.30. Okay? Because of rounding, it might, oh, now I messed it. Because of rounding, it might come out a little bit off. Okay? But if you add those, oh, what have I done to it? Add those up. There you go. It should always come out to 17.30. Hey, and that's actually how you could make an ellipse. If you had like a bulletin board, if you put 2 pins in it, okay, where B and C are, and you take a piece of, like a loop of string, put it around the pins. It can be as big or small as you want, just as long as it can go around the pins. Stretch it tight, pull your pencil against it, and that's how you could make an ellipse. You just need 2 fixed points and a loop of string and pull it tight. Kind of like with a circle. Okay, except with a circle, how many fixed points do you need to make a circle? Yeah, just one. Okay, you could just put a push pin in, tie a piece of string to it, and just pull it tight around, and you could make a circle. Okay, so that's an ellipse. Okay, generally, the first thing we look at with any conic section is all the vocabulary. So I'll explain all the terms we need to know, and then we'll get into some examples. All right, those two fixed points, okay, like the push pins, that's how I refer to them, those are called your foci. That's the plural of the word, does anybody know? What is it? No. Yeah? Focus. Yep. So we didn't study a parabola. Yeah, it was a good guess. We didn't study a parabola, but in a parabola there is a single focus. In an ellipse, there's two of them, and we don't call them focuses. We call them foci. Okay, and there's a few terms in this diagram I'll explain, but this is basically what I just showed you on the other page. Okay, this is the definition of a parabola written as an equation. If you measure the distance from any point to the first focus, and then that same point to the second focus, and you add those two distances up, it always comes out the same. Okay, so that's a short way to write the definition. Okay, and I'll talk about some of the other things labeled in this diagram in a second. Okay, if you draw a line right through the two foci, okay, that axis that goes horizontal, in this case, it could be vertical if we rotate it, is called the major axis. Okay, the major axis goes right through your foci. Okay, major axis is a term we only talk about with ellipses. There's no such thing as a major axis in a circle, in a parabola, or a hyperbola. Okay, so we won't see this term ever again after ellipses. Right. If you connect the two foci with a segment and you find the midpoint between the two foci, that's called the center. Okay, so whatever's halfway between the two foci, that's the center of your ellipse. And we'll see in a little bit, the center is an important point. Okay, we always need to know where the center is if we're going to write the equation. Now, if you draw a line right through the center, perpendicular to the major axis, okay, you get the minor axis. Let's see if I can show you that at the same time. Okay, line right through the center, perpendicular to the major axis, that's the minor axis. Okay, minor axis is a term we will only see today. Okay, we won't see that when we talk about hyperbolas tomorrow. Anybody have a guess what V1 and V2 are? Those are the points where the ellipse crosses the major axis. Guess what V1 and V2 would be? What word?
S1, S2.
No, V stands for something. It's a word that begins with V.
Vector.
Not vector. It's a good guess. But this word also starts with the same two letters vector starts with. No, not velocity. It's a good guess. That's a VE word.
Vertices.
Vertices, yeah. Okay, and vertices is the plural of vertex. Okay, so the point where your ellipse crosses the major axis, those are your vertices. Okay, so any questions on those terms? Those are pretty much all the basic vocabulary we need to know. Okay, we will see the word vertices again tomorrow. We'll see the word center, and we'll see the word foci. Those are all going to come back tomorrow. Okay, so generally what we try to do is we start off with the simple case for an ellipse, where the center is always at the origin. We'll try drawing or writing the equation of one that goes the long way. Then we'll try doing one that goes vertical, tall way. And then we'll try one where we translate it from the origin. Okay, the ellipse doesn't always have to be at the origin. We can move it up, down, left, or right. One thing we don't do is draw ellipses on like a diagonal. Our ellipse is always either going to be up and down or left to right. Okay, any questions on those terms? All right, so since you don't have the packet for this, I would make sure you copy down the formulas. I might reference the page number, and if you want the packet, I can make it. Otherwise, if you copy what's on the board, you're all set. All right, so there's two main cases for the equation of an ellipse. There's the case where it's the long way, horizontal, and then the other case is where it's vertical. Okay, the first one I'm going to show you is where the ellipse has the major axis horizontal. Okay, we're going to have the center at the origin. The coordinates of the foci are negative C0 and positive C0. Major axis is the x-axis. Okay, it's horizontal.
What's the foci?
The foci, the coordinates of it are going to be negative C0 and C0. Okay, the vertices are going to have coordinates negative A0 and positive A0. Okay, when we write it, if you want to do something like this, that's fine. Okay, I'm going to explain what A, B, and C are in a second. Okay, so there's the equation of an ellipse. It's x squared over a squared plus y squared over b squared equals 1. Okay, a couple important things. It's always equal to 1. So if you ever have an equation not equal to 1, we have to make it equal to 1. Okay. A is always bigger than B. And B is bigger than 0. So in other words, A and B are always positive, and A has to be bigger than B. And I use this trick to help figure out which way my major axis goes. Okay? Wherever the bigger number is, okay, that's A. Okay? So the bigger number here is under x. If the bigger number is under x, that means the major axis goes in the x direction, horizontal. If the bigger number ends up under y, then that means the major axis is going to go in the y direction, vertical, up to down. So wherever the bigger number is, that's the direction of the major axis. And the other thing we need to know is this equation. Without this, we wouldn't be able to figure out A, B, and C. It's c squared equals a squared minus b squared. Okay, c squared equals a squared minus b squared. Right, so I had written down to graph an ellipse. It's helpful to know the intercepts, and the book mentions that. Figure out where the ellipse crosses the axes. But is it possible you could have an ellipse that doesn't cross any axis? What do you think, Kyle?
I don't know.
You think I could sketch an ellipse that doesn't cross any of these axes if its center wasn't at the origin? I'm sure, Upi?
Yeah, imagine that for one or anyone.
Yeah. Could have an ellipse just in quadrant 1. Okay, so if I said to you, look for the intercepts to graph it, that's not going to help there. Okay? An ellipse doesn't always cross the x and the y-axis. It could, if it was like that. Okay, but not always. All right, so this is a couple things that are going to help us to figure out A, B, and C. A is the distance from the center to the vertex. Okay, so A is the distance from the center of the ellipse to the vertex. Okay, B is the distance from the center to the minor axis. And C is the distance from the center to the foci. Okay, those three things are helpful to know. Okay, so the whole goal when you're writing an equation of an ellipse is you need to find two letters. You need to figure out A, and you need to figure out B. You have an equation that'll help you, and you also have these three facts. And you can really, like I said, I would just abbreviate them the way I did on the side here, and that's good enough. Okay, any questions before we look at some examples? Okay, and I'll keep these three facts up on the side, so in case we need to look back at them, we can. All right, so first problem says find the equation of this ellipse. Okay, and they're going to give me some facts about it. Okay, they tell me the center, they tell me the focus, and they tell me the vertex. Okay, first thing I like to figure out when I have an ellipse is which way the major axis goes. Okay, in this problem, we haven't studied the type of equation where it goes vertical. Okay, we've only done the one where it's horizontal. Just to jump ahead for a second and show you what happens. When we do the case where the major axis goes up and down, A and B are going to switch places. X and Y never move for an ellipse. X is always first, Y is always second. It's A and B that switch places. And remember, A is always the bigger number. Okay? All right. So let me just graph the focus and the vertices. Okay? That can also help you figure out which way your major axis goes. Okay? My focus is 3 units to the right. Now, they didn't write this down, but where else do I have another focus? Yep, it's always have that symmetry. Okay. And we have a vertex at -4, 0. I put that here. And we also have a vertex at +4, 0. Okay. Those are going to be the endpoints of my ellipse, those two dots in red. Okay, the major axis goes right through all those dots. So is that horizontal or vertical? Horizontal. That means we have to put the bigger number under x. If we want it to come out horizontal, put the bigger number under x. Okay, so now let's figure out A, B, and C. Let's start with the focus. What letter does knowing the coordinate of the focus help me figure out? A, B, or C? C, yep. C is the distance from the center to the focus. What's the distance from the center to the focus here? Yeah, it's 3 units. Okay, so we know C is 3. What about knowing the vertex? What letter does that help me figure out? Yep, A. A is the distance from the center to the vertex, which is how many units? 4 units. Remember, A and B are always positive numbers. Now I've got A, I've got C. The problem is to write the equation, I need B. So how can I use A and C to find B? Yeah, use that formula. It's kind of like the Pythagorean theorem, but it's minus. Okay, be careful with that. C squared equals A squared minus B squared. All right, so C squared. Pat, what's 3 squared? 9. Derek, how about A squared? 16. Okay, and Tyler, what would be my next step to solve that? Yep, minus the 16. Yep, negative 7. Yep, you can change the sign because you have a negative on each side. You can cancel that out.
And then square root of B squared.
And then B, right. Now, really, I need to know B squared. Okay? That's what's going to go right there, B squared. So B squared is 7. If you wanted to write B, as Upi just said, B is the square root of 7. Okay. Now I'm just going to go back to my formula, plug in the numbers I have, and that's it. This is how every single equation for an ellipse is always going to look if the center is at the origin. We just have to decide, where do we put A, where do we put B. Okay. We said our major axis goes in which direction here? Horizontal or vertical? Horizontal. So put the bigger number under X. Okay. That'll make it horizontal. What's the bigger number, A or B? A. So what's A squared?
60.
And what's B squared? 7. That's the equation of your ellipse. If you switch the 16 and the 7, what you're going to do is take your ellipse from being horizontal, you're going to make it vertical. Okay? It would be up and down.
Can you write that down with the horizontal and vertical?
Yep. So if you want the, let's just call it the major axis. Okay, major axis horizontal. Put bigger number under, or I'll say it like this, put A squared under X squared. Okay, if you want major axis vertical, put A squared under Y squared. Okay, we haven't really gotten to the second one yet. You're going to see this when I get to the next equation. Okay. Any question on that? Okay, it takes a little practice to get used to conic sections, but once you get used to it, it's not too bad. You're really just plugging stuff into a formula. All right, so this one a little different. I've given you the equation. I just want you to tell me all about it.
Like, did we solve X squared by 16, or is that what you believe
That's the final answer right there. Yep. Just like when you write an equation in y equals mx plus b, you always leave the x, you always leave the y, but you fill in for all the other numbers.
So it just equals 1?
It always has to equal 1, yes.
Okay.
Yep. All right, so this one I want to discuss. Okay, discuss means describe everything you can about it. For an ellipse, that means tell me the vertices, tell me the foci, tell me the direction of the major axis, tell me the center, and I think that's good enough. Okay, first step to discuss it is to find A, B, and C. Okay, looking at that equation, we are not quite given two of the numbers, but we can find two of the numbers using the denominators. Anyone think they can tell me one of the numbers? Yeah? What is that?
Would that be your vertex?
So you said 5, so our choices are A, B, or C?
Oh, so that would be C.
A. Okay, remember in the formula, one of these is A squared, one of these is B squared. Okay, there's no C in the formula, but C is important to finding the foci. Okay, what other number do we have?
B would be 3.
Yep, B is 3. And now, to discuss the foci, eventually we got to have C. Okay, so we really need to find that. So C squared equals A squared minus B squared. So we're going to have,
Minus 19.
yep, 25 minus 9, which is how much? So what's C?
4.
C is 4. Right, now we know the 3 letters. That's going to help us to describe everything we need to. Okay, where's my center for this ellipse? In fact, it's the only center we've talked about so far. 0, 0. Okay, you'll know when the center is not 0, 0. The equation looks a little different. Right, so my center is 0, 0. How about my vertex? Or, I'm sorry, vertices.
5.
Let's see. Yep, 5, 0, and where else?
Well, negative 5, 0.
Yep. So what I'm going to do is just write it like that. Positive and negative 5, 0. Okay, something else I should write down. Which way does the major axis go? Horizontal or vertical?
Horizontal.
Horizontal. Okay, so once we know the major axis is horizontal, everything is left and right of the center. If the major axis was vertical, things would be above and below the center. What else do I need to describe? One more thing. Yep, the foci. Good. How many units away from the origin are the foci?
4.
4? Are they above and below, or are they left and right? Left and right. 4 units left, 4 units right. That's it. Those are the 4 things you need to describe when you discuss an ellipse. Any questions on that? Okay, always start by finding A, B, and C. I think that's the easiest. Okay, does anyone have any questions on that case before we move on to the vertical case? All right. So we're going to see here a lot of things are similar. Okay, center is still going to be at the origin. The foci are going to be C units away from the center, but the difference now is the foci are going to be above and below the center, not left and right. And that's because the major axis is now going to be up and down. Okay, so we're talking about ellipses that are vertical, not horizontal. Okay, vertices, still A units away from the center. Difference, A units above, A units below. Okay, all the other information about A, B, and C is the same. A is still bigger than B. B is still bigger than 0. And we still use C squared equals A squared minus B squared. No change there. Okay, I think I already mentioned it, but anybody tell me the only difference between this equation and the one you just had?
B and A are switched.
Yep, that's it. Just switch the A and the B. Now, because you're putting the bigger number under y, that causes the vertical axis to be up and down. It's the only difference. Okay, any questions on what's up here before we look at an example? All right. Okay, this one, similar to the last one, it's asking us to discuss the ellipse, but something is wrong here.
It's like equation.
It's what?
It's like equation. Like 9x plus y.
Okay, it's an equation. The other ones were equations too. As long as it's got an equal sign in it, that makes it an equation. So this is still an equation.
It's 9.
What's 9?
Equals 9.
It equals 9. What's wrong with that? It should equal 1. Okay, if we're going to discuss it, we have to make it equal to 1. So how do I do that? Yeah, divide everything by 9. Here, here, and here. Okay, so now once we do that, we're going to get x squared. What could you put for a denominator if you want to put something? Yeah, the 9's cancel out. Now you're just left with 1. Y squared over 9 equals 1. Now we'll identify A, B, and C, and then we'll discuss it by describing those 4 criteria. All right, what's A here? Careful, A squared is 9. 3. Yep. A is 3. How about B? 1. And C? C squared equals A squared minus B squared. So what's C? Square root of 8. Which, if you reduced it, it would be 2 root 2. Okay, I'll reduce it for this one. All right, so let's start with our major axis. Which way does the major axis go in this one? Horizontal or vertical? And how do you know it's vertical?
Because you use the y, or the y is the bigger one.
How do you know?
Like, are the bigger number is on
Yes.
y?
Yep, bigger number is under y.
Yeah.
Okay, so major axis, vertical. So now when you think about vertices and foci, think above and below. Don't think left and right anymore. All right, where is my center? Yep, again, it's going to be very obvious when it's not 0, 0. Okay, you'll know. Vertices. Okay, how many units away from the center are the vertices?
3.
3 units. Above and below or left and right?
Above and below.
Above and below. So that's going to be 0, up 3, down 3. Okay, and last thing I need to describe is my foci. Good. How many units away from the center are the 2 foci?
2 square root.
Yeah, it's a messy number, 2 square root of 2. Are the foci to the left and the right, or are they above and below? Above and below. So go up 2 root 2 and down 2 root 2. Okay, any questions on that? Yep. Because in my equation, this is b squared. So if you take the square root of 1, you just get 1. Nope. The bigger number is always a. A and b switch places in this equation. Yep. Okay, and let me sketch this one since we haven't We haven't done a sketch. I'll just do one quick sketch, since an ellipse is pretty easy to sketch. Okay, so my vertices, positive, up 3, down 3 from the origin. Up 3, down 3, that's the length of my ellipse. And now my other thing I need to sketch the ellipse is the distance from the center to the minor axis. What letter is that?
B.
B. Okay, so the minor axis, major axis is vertical, minor axis is left and right. B is 1 unit and 1 unit. Those are basically the 4 points that make up my ellipse. Okay, so if I'm going to try to sketch it, it's not perfect, but you get the idea. I think that's all there is to sketching an ellipse. You need to use A and you need to use B. You don't need to sketch C. C are the foci. Those would be inside the ellipse. Those would be like the push pins if you were going to make this with a piece of string. Okay. Right, and we'll try one more before we start to look at the final case. All right, find the equation of the ellipse. It's telling you one of the foci. Why they didn't tell us both of them, I'm not sure. But they told us both vertices. Where's the other focus? If you have one at 0, 2. 0, negative 2. Okay, they didn't write it, but that's okay. Brian, what letter can the focus help me to figure out?
C.
Yep, C, the distance from the center to the focus. Now, technically they didn't give us the center, but think about your vertices. You have one at up 3, you have one down 3. The center has to be exactly halfway between them. So what does that mean the center has to be? 0, 0. Yep. So even though they didn't tell me that, the center is always right in between the vertices. Okay. All right, so Brian told us we can use the focus to figure out C. What's the distance between the center and the focus? 2, yep. Okay, Upi, how about the vertices? What letter does that help me figure out?
A.
A, yep. So distance between the center and the vertex. Taryn? 3, yeah. So distance from center to vertex, doesn't matter which one you measure. It's going to be 3 units. And now figure out B. Tommy Lee, what's my formula for A, B, and C?
B squared minus B squared equals C squared.
Yep. C squared equals A squared minus B squared. So bring the 9 to the other side, you get -5. And just like we did before, you can cancel the negative on each side. So B is the square root of 5. Okay, so now we have enough information. Let's write our equation. Okay, always start out just like that. Okay, now we just decide where should A squared go? Under X or under Y? Yep, everything is vertical here. Okay, look at your vertices. They're on the y-axis. So we're going to put 9 here. What's going to go under x squared? 5. And that's your equation. Technically, you could graph this on the calculator, but you'd have to graph it in 2 pieces. Okay, so we're not going to do that.
Aren't you supposed to subtract 9 from both sides?
So when you subtract the 9, 4 minus 9 gives me negative 5.
So then you just divide by -1.
Yep, and then you can divide by negative 1 just to cancel off that negative. Yep. After a while, some people just look at that and they can tell the answer is going to be b squared equals 5. If you don't show this step, that's fine. Okay, as long as you have the final equation. Okay, anything else on that? Right, so what shape is an ellipse most similar to? Yeah, it's most similar to a circle. In fact, an ellipse is just a special case of a circle where A and B are the same. Okay, so if A and B are the same, what they normally do when they write it is they multiply everything by A squared, and they move that A squared to the other side. And that's the equation of a circle. And for A, when we write it as a circle, they usually don't use A and B. They usually use R. Anybody have a guess what R would stand for?
Radius.
Yeah, it's the radius. Okay, and that's all I'm going to say about a circle. We're not going to study it anymore. Okay, so I just want you to think a circle is a special case of an ellipse where both denominators are the same. Okay, so the last case we're going to look at is when the center is not at the origin. Okay, moving it left, right, up, or down. Okay, and if you understand how to do it where the center is at the origin, when it's not at the origin, it's really not that much harder. Does everybody have that? So, most important thing to know when you shift an ellipse, this is the letters we use for the center, H and K. Right, so when our major axis is horizontal, okay, always put the A under x squared, that makes it horizontal. Put the B under y squared, it's still equal to 1. The only difference is now in the numerator, you have x minus h instead of just x. Okay? And in the other numerator, you have y minus k instead of just y. H and k are the coordinates of the center. And notice it's always written as a minus. So whatever comes after the minus sign, that's h. Whatever comes after the other minus sign, that's k. So you have to be careful if you ever get an equation with a plus. Okay, we've dealt with that before. Okay, you already know both of these facts already. A is bigger than B, B is greater than 0. Kind of looks like the Pythagorean theorem, except with a minus. And what do you think the only thing that's going to change when the major axis is vertical? A and B are going to switch. That's it. Okay. X is always with H. Y is always with K. A squared is always under whatever letter you want the major axis to follow. Okay, in the packet, this is on page 394. If anybody wants a copy of that page, I can give it to you. But if you have these two equations, that's all you need.
Is it a K or H for the second one? That's K.
Yeah, y minus k. Any questions on those equations? I didn't mention it, but notice they're both still equal to 1. That doesn't change. Okay. All right, so we'll try one finding the equation, and I'll be up. All Right, so now when you find the equation, you still have to find A, B, and C, but you also have to find H and K. Okay, H and K are usually very, very quick to find. Okay, anyone think they can tell me what H is going to be? 2.
And you will be -3.
And K is -3. Remember, H and K are just the coordinates of the center. That's H, that's K. There's usually no arithmetic you need to do to find that. Okay, now A, B, and C. A is the distance from the center to the vertex. Anyone think they can tell me the distance between the center and the vertex?
2, 0.
What is it?
2, or would it be 2, 0?
It's just a single number, but it's not
Oh, 3.
2. Yeah, it's 3. Okay, 2 of these numbers are the same. Okay, so if you have trouble, just sketch it out. The center is 2 units right, 3 units down. Here's your center. Your vertex is 5 units right, 3 units down. So if I look at the distance between them, 1, 2, 3. Okay, how about, what can I get next, B or C?
D.
B? Do I know the distance from the center to the minor axis?
I think you can see.
No, I don't know that, but I do know the distance from the center to the focus. How far apart are those? 1. Yep. And now we can get B using our formula. C squared equals A squared minus B squared. Okay, what's B squared going to come out to? Yes, correct. B squared is 8. So what's B?
Square root of
Yep, 2 square roots of 2.
Will it be -8 because -9 from the square?
So when you subtract the 9, you're going to get
Oh.
-8, but then that negative and that negative cancel. All right, so now just write out our equation. Something squared plus something squared equals 1. Okay, what letter always goes with X?
H.
H. Is it, and it's going to be X minus H. So what's that first numerator going to become?
2.
X minus 2. Okay, second numerator is Y minus K.
Y plus 3.
Yes, okay, it's going to be Y plus 3. This is where people get tripped up sometime. If I say, what's K? They say, oh, it's 3. Nope. K is always what comes after the minus sign. Okay, so K is really -3. Okay, H is 2. Okay, so you got to be careful with that. Which way does our major axis go if it's going to go through those points? Horizontal or vertical? Horizontal. So I want the bigger number under X. Bigger number between A and B is A. Okay. What do you get if you square A? 9. How about if you square B?
8.
8. And that's almost a circle. If you were to sketch it, it wouldn't look very elliptical. It's almost a circle, but not quite. Okay. Any questions on that one?
Could you grab this on a calculator? Or?
Yeah. You could graph it. You'd have to get Y by itself. So it'd be a little messy, but yes. If we have time while you guys start the homework, I'll try a simple one and show you.
How did you know that it was 1? C.
How did we know C was 1?
Yeah.
So C is the distance from the center to the focus. And we were given the center and we were given the focus. And the difference between 3 and 2 is 1.
How did you know it was horizontal, not vertical?
Horizontal, because I graphed the center, and then I graphed the vertex, and I could see they lined up horizontally. So you just graph all these points and see how they line up. They're either going to line up horizontally, which means all the y values are the same, or they're going to line up vertically, which means all the x values would have been the same. Okay, but I guarantee anytime I give you a problem like this, I'll make sure all the y's are the same or all the x's are the same. They have to be. Okay, yeah, good question. Any other questions? All right. Okay, so that's the homework. Okay, so it's page 397. Okay, all odds, 13 to 17 odd, 21, 27 to 31 odd, and 39 to 45 odd. Okay, I'll put up the assignment, so I'll make sure that's in the video, so you can either get it online, or if you want to take a picture of it, it'll be on the screen, you could do that as well.